Hey guys, Mr. Shaw here. The next skill that we're going to be looking at today is to identify proportional relationships from graphs and equations. You can search for this skill using NB5. So if I look at these two graphs, they both look like they are linear equations. For some reason you forget how to identify if something is linear or nonlinear in a function on a graph. You can always look at Tuesday's video where we went over that skill. If I take a look at both of these though, I notice that they hit the axis at different places. It looks like that first graph hits somewhere between 1 and 2 on the x-axis, and then the second graph hits right at 0 at the origin. To find a proportional relationship, you basically need two criteria. The first thing is that it needs to be a straight line. Both of these are. But the second is that that graph needs to actually hit at the origin. It shouldn't hit anywhere else. That lets me know that there's no y-intercept, that the two x and y values are basically just directly proportional to each other. When there's a y-intercept, though, it's going to move that graph up or down, and what that really means is that there's some sort of shift between the x and the y value that makes it not proportional. So I think it's just the second graph, and I'll try it, and it tells me yes. So for each of these, I want to hit those two boxes. First, is it a straight line? Second, does it pass through the origin? So both of these are straight lines. They're linear functions. So let me go ahead and pick both, but then let me double check. Yep, this one hits at the origin, and this one hits the origin. I think both of them are going to be proportional relationships. So let me submit it and check. Sweet. Now, I don't know if you've seen this on some of these skills, but sometimes if you're having trouble with a skill, IXL is actually going to suggest something that might be easier for you to do to learn what that skill needs underneath. If you haven't mastered what's underneath it, you might not feel as confident with the skill itself. So if you find yourself having trouble with this skill, even after this video, take a look down here, click this link, and try this skill first. Alright, ooh, equations. A lot of you get triggered by equations because they don't look as clear as the graph, but it still means the same thing. We just need to think about what this would look like in a graph. So y equals 3x plus 9, y equals x. The difference between these two equations is that this one has a y-intercept that isn't 0, plus 9. That means that the graph is going to be offset 9 ticks up on the y-axis, which means that those two, x and y, aren't going to be proportional. So I'm only going to pick y equals x because there's no y-intercept other than 0, which we don't even see written here. And that's right. If the y-intercept is not shown in the equation, it means that it's 0, and if it's 0, it means that that line is going to hit at the origin. So I'm looking for equations where the y-intercept is 0, and that lets me know that when I graph it, it's going to come through the origin. In both of these, I don't see a y-intercept. I see y equals 8x, y equals 6x. So let me check both of those off. Tells me it's right. I feel so good about this. All right, two more straight lines. I'm looking to see, think in your head, which one of these would be the right one, because one of them doesn't go through the origin. If you picked this one, you got it right. And so did I. All right, I've got two equations. Think in your head which one of these two equations would be proportional. Hopefully in your head you're thinking, or out loud you're thinking, both, not just one, because neither of them has a y-intercept that isn't 0. All right. Oh, cool, I don't see a y-intercept in either of these either. But wait a second. Y equals 7. I know that I learned in math class that's not going to get graphed as like a y-x line. That's just going to be a line that goes through y. If there isn't an x, it can't be proportional between y and x because there's no relationship shown between y and x. There's got to be a relationship of some kind. So I'm not going to select this one. I made the right call. Now, in some cases, you're going to see some questions where you won't see straight lines at all. In that case, we have to jump back to our previous criteria of what makes it a proportional relationship. And I'm going to jump ahead a couple questions to make sure that I can find an example for you. Blah, 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 blah. Blah, 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 blah. Who's fast as Mr. Shaw? He's the Flash. He's not the Flash. Well, guys, I'm really trying. Here's a good example. So I see two straight lines here. Clearly, only one of them passes through the origin. This is just like the equation we saw earlier where y equals 7. In this case, y wouldn't equal 7, it would equal 8. But there's no relationship with the x-axis at all. There's nothing going on down here. So I can't say that there's a proportional relationship because it's not passing through the origin. And even though it's a straight line, there's no relationship with the x-axis at all anywhere. Okay. Mr. Shaw might end up getting a smart score of 100 before he can even show you the type of example that he wanted to, but we'll see. Come on, IXL. Show me a curvy line. Oh, we're in the challenge zone now, guys. What? The challenge zone? If you make it to the challenge zone, it's the same rules. So here, I see these fractions. Fractions scare people away. But if the y-intercept is 0, it's proportional. If the y-intercept isn't 0, it's not proportional. It doesn't matter if it's a fraction or not. I promise, guys, when I was doing this, there we go. Oh my goodness. 10 questions later, more than that. So you'll notice here, both of these pass through the origin. But the second rule, really the first rule that I should explain, was that they have to be a straight line to be proportional. So here I see a straight line, but this one is curvy lined. Again, feel free to reference back to Tuesday's video if you want to identify between linear and nonlinear functions. But for it to be proportional, it's got to meet both criteria, being linear and passing through the origin. All right, y'all, go hit that smart score of 80 or higher, and I will catch you on the other side.